In this lesson, we're going to be working with Bollinger Bands. Now, I'm going to create a very simple example, but with some advanced features, not in terms of analysis, but more in terms of how we display our Bollinger Band analysis. So the purpose of this script is we want to detect expansion and contraction in the Bollinger Bands themselves. This was a question asked by Gab, I believe, in the Discord. I'll put a screenshot here of his question from the Discord. And he wanted to know how to do something in Pine that is relatively simple, but kind of confusing, especially for a beginner coder to try and figure out how to do, especially if you're mathematically dyslexic like I am. This script took a little bit longer than it probably should have for me to put together, but I think it's a great example of how to analyze indicator values in Pine in a creative manner. Let me paste the final code in to give you a visual example of what we're going to create in this lesson. So when the script loads, here we go. So what this script is doing is it's plotting a standard vanilla Bollinger Band indicator onto our chart, standard 20 SMA base, and one standard deviation above and below that moving average. Now, for those of you who are not familiar with Bollinger Bands, I personally am not super experienced in using them in trading strategies, but I do understand a few techniques that can be used with Bollinger Bands. They are a very interesting price analysis tool. A lot of reputable traders use this indicator in their strategies. In the next lesson, I'll show you a more practical strategy type approach for using Bollinger Bands. But for today's lesson, what we're doing here is just detecting expansion and contraction in the deviation of the bands. What this gives us is a read on volatility. So as the bands expand, that means price action volatility is expanding, and you can see the background of our Bollinger Band turns a brighter green as the bands expand. And then the background turns red as the bands contract. As the bands contract towards price action, the background of our chart starts to turn red. So that's what we're going to do in today's lesson. We are also going to add alert functionality to the script. And so without further ado, let's get into today's lesson. So first of all, I've got the inbuilt Bollinger Band indicator added to my chart here. This is the TradingView inbuilt indicator. Now, if you want to understand more about how Bollinger Bands work in Pine, you can open up the source code to this inbuilt script. And it's quite simple. All we're doing is calculating an SMA based on a price source and a period length, so a look back length. And then we calculate a deviation, a standard deviation multiplied by our standard deviation multiplier. And so the orange line is our SMA, the upper band is one standard deviation above that SMA, and the lower band is one standard deviation below the band. We are going to create this exact same indicator, but with a few more bells and whistles. So if I remove this script, open up the source code to this one, let me explain what we're doing here. First of all, just a standard indicator with overlay set to true so that we can draw over price action. We're getting a couple of user inputs here. We're going to end up getting a lot more user inputs throughout the lesson, but I wanted to start simple and build from here so I don't overwhelm you with too much information straight out of the gate. So what we have here is our standard deviation input and our moving average length. And maybe we should swap these around now that I think about it. So if I open up my settings menu, we have our middle SMA length, which is 20 by default, and our standard deviation multiplier, which is 2 by default. And I've set up some tooltips that explain what these inputs do using the tooltip input parameter. I've set the step of our standard deviation to 0.5. All that means is that when we click on the up and down arrows here, the value will increment or decrement by 0.5, which just makes these arrows a little bit more useful. And that's the only two inputs we need in order to calculate our standard vanilla Bollinger Band values. So let's do that next. Get Bollinger Bands. So the way that Bollinger Bands work, the inbuilt Bollinger Band function in Pine, is very similar to the MACD. And by that I mean we need to get multiple values from one indicator call using the tuple syntax. So I'll show you what I mean. We are going to be using the ta.bb, short for Bollinger Band function. If I hover over this little function name and we read the tooltip, you can see down here that it returns multiple values. It returns 3 float values. And those 3 float values are the Bollinger Band middle value, our SMA, the Bollinger Band high or upper band, and the Bollinger Band low or lower band. You could call this BB upper, but I think high and low makes more sense in a coding context. So I'm just going to call mine BB mid, BB high, BB low. And then we need to pass in the three input values that our Bollinger Band requires in order to calculate its three bands. And that is a price source. So this is usually done with a closing price, but you can obviously change this to anything. Doesn't even need to be a price value, just needs to be a float value. So you could calculate Bollinger Band values on other indicator values. If you wanted to start getting a bit Leonardo DiCaprio with your price action analysis and start performing indicator inception, for now we're just going to reference the closing price. The next value we need is our moving average period. So MA period in this case is our user input here, 20 by default. And then we need to put in our standard deviation multiplier. So for this, I just called mine standard DEV. That's this user input here, so 2.0 by default. And that's it. We now have our Bollinger Band values, and we can plot these to the chart. So if I plot BB mid, copy this, paste in two more, and copy these into the plots, and save my code, we now have our Bollinger Bands drawing onto the chart. And if I throw on the inbuilt Bollinger Bands indicator, the values should be identical, and they are. So perfect. So far, so good. We have the foundations of our script. We will format our plots later on to be a little more easy on the eyes, but for now we'll leave these and we'll move on to the next part of our script, which is calculating the change in percentage of our upper and lower bands. So in this script, we are using a single standard deviation for both bands. What that means is each band will be an equal distance from the middle band. In the next lesson, I will show you how to calculate an upper band and a lower band with different unique standard deviation multipliers. But for this lesson, we're going to keep things simple. We're just working with one standard deviation multiplier, which means that we can calculate the percentage change in our upper band, and that will still apply to our lower band. What I mean by that is if the upper band is shrinking towards price action or contracting, that means the lower band will also be contracting towards price action. And obviously the opposite, if they are expanding, both bands will be expanding outwards. So our code for calculating the percentage change in the Bollinger Band expansion or contraction is going to look like this. Calculate percentage change in bands. The first thing we need to do is get our BB change, our Bollinger Band change between the upper band and our middle band. So to do that, BB high minus BB low, BB mid. What am I doing? It's early in the morning here. Then we need to get the difference between our BB change on the current bar and the BB change on the previous bar. So here I can say BB diff equals BB change minus BB change. And then I can put a 1 in there, and that will calculate the difference between the current bar's Bollinger Band value and the previous bar's Bollinger Band value. And then we need to convert that into a percentage. So I'll create another variable here called BB_PCT, short for percent. So BB percent equals BB difference divided by BB change, multiplied by 100 to convert this into a whole number. So before we continue, let's plot this BB percentage onto the chart. I'll give it a color of color.purple, actually a color new color.purple with 100% transparency, so it doesn't actually draw onto the chart. It's invisible. Save our code, and here we go. We have our Bollinger Bands drawing, and this purple number up here represents the percentage change between the current bar's upper band distance to the middle band and the previous bar. So if I hover over this current bar, the last bar on my chart, you can see it says -18 up there. That means that the band dropped 18% against the previous band's value, numerical value, not price value. So it definitely did not drop 18% in price terms, but in terms of the Bollinger Band value of the current bar compared to the previous bar, that was an 18% contraction. So far so good, but it's not that useful to compare the Bollinger Band contraction to the previous bar. I want to be able to compare it to a bar, let's say 10 bars ago. So what I'm going to do here is add another user input. I'm going to add a look back input. So this look back input is just an integer input. It has a default value of 10, and the tooltip here just says look back period for calculating Bollinger Band percentage change. So now I can replace this 1 with our look back input. And now when I save my code, we should be getting the percentage change between the current Bollinger Band value and the Bollinger Band value from 10 bars ago. And we're not comparing the upper band to itself, we're comparing the distance between the upper band and the middle band. So that's why here it says minus 94.28. That's because the distance between our upper band here and our upper band here has contracted by 94.28%. So we have a very large contraction between the distance of our bands from our middle point. What this means is that price action is entering perhaps a period of consolidation. We're coiling. Price is trading closer to its central moving average over a longer period of time, and therefore volatility is contracting, and that could mean all kinds of things. It could mean we're about to enter a period of consolidation, which I'd say is likely given this big run up here. Or we could even be potentially entering a reversal zone. So here's a good example where the bands began contracting towards the central moving average. We consolidated for a while and then we rolled over. This could be the early signs of that about to happen. But anyway, let's continue with our code. I'll cut this plot out and put it down here. And I'll also title this. Title equals Bollinger change percentage. And let's format our other plots while we're here. I'll set this to color equals color.blue. And I'll give it a title of mid SMA. And I'll set the others to red and green. There we go. Save my code. We should have a red upper band, green lower band, and a blue middle band. All right, so now we have calculated our percentage change in contraction and expansion from our central band to our upper and lower bands. Let's do our color coding of the price between the bands. So we want to fill the background of our chart between these two bands with a specified color based on how dramatically the Bollinger Bands are expanding or contracting. So to do that, I'll expand our code a bit here. I'll say here, change background of chart based on Bollinger Band expansion / contraction. And what I'm going to do here is generate a background color from a gradient. We're going to use the color gradient function to automatically generate a color between two different colors based on this purple number here. So I'll show you what I mean. I'm going to set BG color to color.from_gradient. Now this function here takes 5 parameters, takes a value, a bottom value and a top value, and then a bottom color and top color. So the value we want to analyze is going to be our BB percentage value. The bottom value we'll just set to minus 100 for now, and I'm going to set this to a float number. And the upper value we'll set to positive 100 for now. We'll change these in a moment, but this is just to get the code written and then we can modify it. The next thing we need to do is set our lower color and our upper color. So I'll set the lower color to color.new, open parentheses, color.red, and I'll set the transparency to something like 75% so it's not super bright. And then I'll do the same for our next color, which is the upper color. So the closer our BB percentage value is to this lower number, the closer the color will be to this color. And the closer our BB percentage value is to this value, the closer the color will be to this color. So this will be color.new, color.lime green with 75% transparency. Close off those parentheses, and we now have our background color. All we have to do now is fill the background color of our chart with this BG color value. But to do that, we need to tell this fill function which values to fill between. In this case, that's our upper band and lower band. To do this, I'm going to create 2 new variables here. I'm going to assign these 2 plots to 2 values. So I'll just call these X and Y. So now X will be set to our upper band and Y will be set to our lower band plots. And now we can fill between our X and Y plot and set our background color. So watch what happens now when I save my code. Watch what happens between our upper and lower bands. There we go. We now have this gradient color that turns darker red as the bands contract and green as the bands expand away from our central moving average. So we are nearly done with our script, but there are a couple of adjustments I want to make, and I want to add a bunch of extra user inputs to the script. So first of all, if you look at our purple number, as we move across price action, you can see that the value gets much lower than minus 100 at times. Let me find an example. Over here, it gets as far down as negative 179, and in some places as far as minus 200. And if you look at this purple number when the bands are expanding, they rarely get anywhere close to 100. They're usually, sometimes they do, but they're usually closer to around 60 is about as high as it typically gets, at least on this market. And so what I'm going to do is I'm going to use a for loop to look back over past price action to get the maximum and minimum change percentage of our Bollinger Band expansion and contraction. And I'm going to use those values to dictate how bright the green or red color gets on our chart as these bands are expanding and contracting. So I'll show you what I mean here. I'm going to create a new block of code here called get largest expansion / contraction percentage over the past X bars. And I need to create two new variables here. One is going to be max expansion and max contraction. And max expansion is going to be set to 0.0 and max contraction is also 0.0. And then we're going to override these values based on what our for loop detects over our look back period. So I'm going to set a for loop here, I equals 0 to, and instead of just looking back on our look back period, which is 10 by default, I want to actually look back double our look back period. I think in my testing, this just gave a more accurate reading on significant volatility, expansion or contraction. So what I mean by that is, if you only look over our look back period, all through here, our background color will be bright lime green, just because the band is constantly making new higher values over each bar. So this is completely optional, but I like to have a further look back period for our maximum expansion and contraction values so that we get a brighter color when we have significant expansion or contraction in our bands over recent price action. So we're going to start from 0 and loop up to our look back period multiplied by 2. By default, that will be 20. And on each bar that we loop over in our for loop, we're going to check if BB percentage on that particular bar is greater than our max expansion value, then assign our max expansion value to that percentage value on that bar. And same for our maximum contraction. So if BB percentage value on the current looped bar is less than our max contraction value, then max con is set to or reassigned to BB percentage on that bar that we're looping over, that historical bar looking left. So that's it. We are now calculating our maximum expansion and contraction as a percentage value over our look back period times 2. And what we can do now is pass in our max expansion into our upper number here in our gradient function and our max contraction value into our minimum gradient value. Save our code. And now we're getting a little bit more information here. The background color is probably hard to see. You'll need to play around with this code yourself. Play around with this look back period to see, or this look back period multiplier in our for loop to see how that affects your color gradients on your chart. But anyway, the script now is pretty much completed. There's just a couple more things I want to do. I want to add a bunch of extra inputs here. So I'm going to just paste these in to save time because they're not that important. But what we have here is some alert inputs. So the script will generate alerts whenever the expansion percentage exceeds this value. And the contraction alert will trigger an alert whenever the contraction value exceeds, the percentage value exceeds this negative value. So what I mean by that is it's set to minus 40 by default. So as soon as this purple number hits minus 40, like you see here, it goes from minus 26% to minus 52%. That would generate an alert if you set one up in the settings menu, at least when we've finished coding our script. And then the final two inputs are just our expansion color and our contraction color. And for these inputs, we're using the color input, and we're assigning the color to the same colors we are using in our hard-coded function down here. So color.line with 75% transparency and color.red with 75% transparency. And we are also using the inline parameter here just to show you guys how that works. If I save my code and open up the settings menu, we now have a bunch of new settings, our expansion and contraction alerts, and our expansion and contraction colors. And you can see that our color inputs are on the same line. That's what the inline parameter does. If you assign it the same string, it will be placed in the same line of our settings menu. And the tooltip will apply to both or all of the inputs that you put on that line. So that's why our tooltip here is only on the second input, and it just says max expansion / contraction color gradient. If you open this up, you can change the color and the percentage here of transparency. So if I copy this expansion color into our color.line value in this from gradient function call, and the contraction color into the bottom color parameter, now when we save our code and open up the settings menu, we can change the transparency of our colors, and we can also change the colors themselves. So let's change this to purple and this to sort of aqua color. There you go. You can get some pretty psychedelic looking color schemes on your chart using the from gradient function. I thought this was a great opportunity to show how to use that function, because it's not often that you will find a practical use case for that function, but this is a good example of what that could be useful for. So let's reset our settings and let's play with our look back period a little bit. I wouldn't play around with the look back period too much from 10 bars, because the further back you look, the less relevant that is to current price action. So if you wanted to, you could even shrink this a bit to 5-bar look back, and now it's a lot more responsive to when the bands start contracting towards the central moving average. Anyway, let's wrap up this script by adding alert functionality, which is very easy to do. I'll just copy the code over to save time. There we go. So we're using two alert condition functions here. If our Bollinger Band percentage change, our purple number here, is greater than or equal to our expansion alert value in our settings menu, then this alert will fire. And this message will be sent to your phone or email or however you set up your alerts. It will include the symbol name and the expansion percentage. So the plot _0 placeholder will be replaced with the very first plot on our chart from this indicator. And that is our percentage expansion and contraction value. And then obviously the same for our contraction alert, but the opposite direction. We are checking if the Bollinger Band contraction percentage value is less than or equal to our contraction alert value in here. And so now if I get rid of our white space, save our code, there is our completed script. And if I come up to the settings menu, let me set this back to its default settings, come up to the settings menu, select our script, and we have our Bollinger Band volatility alert options here. Plus means expanding, and the minus sign means contracting. And that's it for today's lesson. Hope you found this interesting. The source code, as always, will be below if you want to play around with this. And in the next lesson, we are going to expand on what we learned here and build a trading tool based on Bollinger Band volatility. Well, it's more of an investment tool, but we'll cover that in the next lesson. I'll see you there.